Hello and welcome to your Ed puzzle that's going to go over how to factor out the GCF. So we're going to go through the learning target first, and then we'll kind of review what a greatest common factor is, and then we're getting to how that is applicable to this lesson. Alright, so today our learning target is, today we'll find and factor out the GCF of a trinomial so that I can rewrite an expression as a product of its factors. Let's have a still in there. I know that I've got it when I can factor out the GCF, and there's a binomial, but it's the same idea of 4x squared plus 2x. So that's what our target is today. We're actually going to be doing the opposite of multiplying. We're going to be pulling out the greatest common factor. So just to review over what the, let me move my head over here so it's not in the way. Whoop. Okay. So to review over what the greatest common factor is, the greatest common factor is what is the biggest number that both terms or more than one terms can divide by. So the biggest integer you can divide every term that you have by. So like if you're talking about 18 and 24, the largest, they're both divisible by 2, they're both divisible by 3, but the largest number they're divisible by evenly is 6. So that's how you talk about what the greatest of the factors are. A factor is just a number that when you multiply with another number, you get what that original number was. So like factors of 18 would be like 2 and 9, or 6 and 3, or 2, 3, 3. Those are all factors. So what you can do is you can just use your brain and think about what the largest number is. Or you can actually find all the prime factors, kind of making the factor tree like we did when we did simplifying radicals. And then you can use the factors to select what you can multiply together to get the largest factor. So we're going to do it both ways. All right, we'll start out with easy. So in algebra, we can have two things in common. We can have a greatest common factor number, like the coefficient, and also how many of that of a variable you have in common. So if you look at 5 and 25, we can actually just kind of list them out. We have 5x. That is as simple as that gets. And the prime factors of 25 are just 5 and 5. And then we'll just expand out the x squared. So you can tell on here, both terms have 1, 5. They don't both have 2. Both of them have 1, 5. And both of them have 1x. So those are that's your greatest common factor would be for this, would be 5x. That's what both of those terms have in common. They can both be divided by 5, and they can both be divided by x. Alright, so you might have 3 terms in this case. So you can either look at these numbers and think, what can I divide? What's the biggest number I can divide 36, 12, and 6 by? And so using that, you might remember all of your multiplication facts. Hopefully most of you still remember those. And the largest of the numbers, all of those numbers are divisible by 2 because they're even, so that's good. That's not the greatest common factor. All of them are divisible by 3, but the largest number that all of them are divisible by is 6. So they all have a 6, and they all have at least one y. So you have to kind of go with the lowest variable, like as far as the exponent goes. So I have 3 y's for this one here. I have 1 y for that one and 2 y's. So they all have 1 y. So your GCF for this would be 6y. Now let's say your multiplication facts aren't great. That's okay. We can make a factor tree of each term. Nope. It helps if you do the factor tree accurately. And then we'll do one for 12. It's just 3, 4, and 2 and 2. And 6, which is just 3 and 2. So what we're going to look at is all of our ends. And I'm just going to write each one of these terms in expanded form. Oh, sorry, my head's in the way again. So for each one of these, there's a lot going on. But if you can't if you're not great at multiplication facts and you are having a trouble figuring out what they're all divisible by, this is your alternative strategy. So you can list all of our prime factors. So for the 36, 2 times 2 times 3 times 3. And then including the variables as well. So y times y times y. Then for 12y, it'd be 2 times 2 times 3, 1y. And then 2 times 3 and 2 y's. And then you can, I'm just going to use like a blue circle. You can, oops, now I'm like blocking it again. Sorry. You can actually circle what each one of them has. So they all have 1, 2. They don't all have 2 2s. The first 2 do, but the last term does not. They all have 1, 3. They all have 1 y. That's what they have in common. And so once you figure out what they all have in common, you just multiply all those together. And that's going to be 6y. So again, that's just an alternative strategy. So you can either list all the factors and then circle what they have in common, or you can just look at it and say they all can be divided by this largest number, and then they all have at least this one variable. Okay, so for one more, I'll do it both ways. So I'll start with just doing the factor tree. So this would be just 2 and 7, and this would just be 2. There's no factor tree for this one, it's just 2. So once you get that done, you are going to rewrite it. So 2 times 2 times 7, 1, 2, 3 y's, 2 times 7, 2, and then yy. And what they all have in common is that they all have a 2, a 7, a 2, a 7, and then a 2. So that one actually, they don't have the 7 in common. This is distraction, sorry. I just erased one of those guys there too. There we go. So we have, only thing that all those numbers can be divided by is 2. That's it. So the greatest common factor for this one is 2. And again, you can look at this just from the start. They're all divisible by 2. The 14 doesn't have a y, so we can't even have a y in our greatest common factor. All right, so that's kind of the prelude, even though we're 7 minutes in to the video. We'll do a couple of these pretty fast. So that means that the hardest part of these is going to be finding what the GCF is. We're actually going to take that term in these certain polynomials, binomials, trinomials, and we're going to take the greatest common factor and we're actually going to divide it out from each term. So we're going to almost do reverse distributive property. The first thing you want to do is find what the GCF is, and then after that you want to undistribute. So you want to take out that, divide that each term that you have by the GCF, and whatever is left is going to go in parentheses. So this is kind of going back to the first part up there, but we have 5x plus 25x squared. So both of them can be divided by 5, and they both have 1x. The second one has 2 x's, but the first one has 1. So that's going to be what your GCF is. Now when you're actually factoring out, that's the real lesson of today, you're going to take the GCF and you're going to stick it on the outside of the parentheses. And then on the inside, we're going to have 2 terms left. We're going to have the term that's left from when I divide each one of the terms, the 5x and the 25x squared, by 5x. So if I take this and I divide it by 5x, hopefully we know that that's going to be a 1. So I'm going to put a 1 there. If I take the 25x squared and divide it by 5x, that's going to be 5x. Now you can check it. I'm just going to do a quick check in pink just so you can see it. The check is, if I take what I wrote, what your answer is, and if I actually distribute it through, then that would give me the correct answer, what you started with. So you're saying here, right here is the distributive part. That's what we've distributed. We're going backwards from that. Okay, let's do a couple of more. I'm going to go over on 10 minutes, but oh well. So we're going to look here at each one of these terms. They all can be 36, 12, and 6. That's what we did earlier. They're all divisible by 2. Yes. 3. Yes. but 6 is the largest number, so that's going to be it. The first one has 3 y's, the second one has 1 y, the last one has 2 y's. They all have, that's a statement you want to make with GCF, 1 y. So that's what our GCF is. So we're going to take our GCF and put it on the outside of the parentheses. And then again, we're going to be reverse distributing. So we're going to divide each term by 6. Y would be that. So from there, if I divide each term by 6y, 36 divided by 6 is 6. Y to the third, and I take one of those y's out, I have y squared. Plus 12 divided by 6, which is 2, y divided by y, which is 1. So 2 times 1 is just 2. And then 6y squared divided by 6y is going to be minus y. So you're just dividing it out. And again, you can even do a quick check off. That's your answer. When they say factor out the GCF, we did. There's the GCF, the 6. We factored it out. We took it out of the parentheses, or we took it out of each term that we had. So if I wanted to do a check, you could then again just multiply it through just to make sure you were right. You can multiply it through on here, and you would get 36y to the third plus 12y minus 6y squared for that one. Okay, I'm going to do one more of these, maybe this one, as the last problem on here. So we're going to see what can we divide 10, 8, and 26 by. So looks like the biggest number, because 10 is 5 and 2. None of the other numbers can be divided by 5. So all of them are divisible by 2. Now sometimes they're not going to have any number. It's only going to have a variable in common. And if there's nothing you divide it by, there just is no GCF. You can't factor it out. So the GCF is going to be 2, and then they all have 1x in common. So it would just be 2x. Okay. So from there, we're going to take the 2x out. And then from this term, I'm going to do 10 divided by negative 10 divided by 2, negative 5. 3x's, I take 1 out, so I have 2x's left. 8 divided by 2, which is 4. 2x's, 1's gone. And then 26 divided by 2 is 13. And the x's, there is none left because we took the only x out. So that'd be your answer for this one. Sometimes you do have, like this one has a GCF of x squared. I don't know why I put this one on here now. Sometimes you actually are going to take out more than one x. But anyway. All right, hopefully this was helpful. We'll see you guys next week during class and go over this again. Thanks for watching.